In clip 6, we're going to be finding the point of intersections of two graphs. This is also the same as solving a system of equations. The instructions specifically are find any points of intersection between the two functions given. If you look at the green comment at the bottom of the page, it says, a quick sketch is helpful in revealing the number of solutions you're trying to find. Now, each of these functions represents a graph, and two graphs can cross in many places. They could cross in just one place. They might not cross at all. So if you take just a few moments to try to get a rough sketch before you get started, you'll at least know how many solutions you're looking for. In the case where there are none, you could just end the process right there and say there are no intersections. So it's definitely worth your time to take a moment and just sketch these things if you can do it quickly. So I'm focusing my attention on this first function, and remembering from Algebra 2 or Pre-Calculus or whichever course, this is the equation of an ellipse, which looks like an oval, and the center of this ellipse is 0, 0, and let's just get some stuff going here with this. So I'm going to make a couple tick marks here, a couple tick marks here, a couple up, and a couple down. Now, because the larger denominator is aligned with the x, I know that it's going to be a horizontally oriented ellipse. And you have to take the square root of each number in the denominator to figure out how far to move away from the center. So the square root of 4 is 2, so I'm going to move 2 units from the center, which is at 0, 0. So let me go back to blue here. So I'm going to go 2 units to the right. I'm going to go 2 units to the left. The square root of 1 is 1, so I'm going to go 1 unit up, and I'm going to go 1 unit down. And these 4 points sort of serve as the basis for the ellipse or the oval, whatever you want to call it. So here we go. Just a little rough sketch. There we go. There's the ellipse. It's far from perfect, but it gives us the idea. Now, in a different color, I'll do this, and this is just a line, so this will be pretty quick. Now, the y-intercept of this line is positive 1, which is where the point on the ellipse was, and it also has a slope of 1. So that means this would have been another point if we rise 1, run 1. So I'm going to just connect these like this. And in doing this very quickly, I see that there are 2 answers that I'm looking for. I need to find out the location of this, and I need to find the location of this. And if I do that, then I've answered the question. So I'm ready to proceed. I think the first thing that I'm going to do is multiply through by 4 to clear the fractions. And in doing that, I end up getting a new equation which says x squared plus 4y squared equals 4. Let me make that plus a little better. And I'm going to work also with y equals x plus 1. I'll leave that unchanged. And the way that I'm going to solve this, and you usually have a couple of options with system of equations. You've got something called substitution. You also have something called elimination. I think in this particular case, I'm going to use substitution, and I'm going to take this expression for y and plug it in for here. So I'm going to have now x squared plus 4 y squared equals 4. And you'll notice I've left a blank space for the y, and this new expression for y is x plus 1. This is going to require some foiling, and I'm going to hold back from doing too much in my head at once. So I'm going to put a plus 4 and then a big grouping symbol for the result of that FOIL, which is going to be x squared plus 2x plus 1. Now I'll distribute the 4 through. I find that if students try to do too many steps in their head at once, that's really where the error happens. It has nothing to do with a student being smart. It just has to do with just taking your time and trying to be as methodical as you can about it. Alright, so I distributed the 4 through. I noticed that there's a 4 on both sides, so they're going to cancel out. And I end up getting 5x squared when I combine my like terms plus 8x equals 0. And I can factor out an x, and that leaves me with 5x plus 8 equals 0. And I'll set each of these factors equal to 0. So in this case, I get x equals 0. And in this case over here, I get x equals negative 8/5. Now each of these answers is going to have a y that goes with it. And you can just plug that back into either one of these, but I think the bottom one will probably be a little more convenient. So in the case where x is 0, y ends up being 1, suggesting the ordered pair 0, 1. And if you look at the graph, sure enough, 0, 1 is absolutely one of the places where these two graphs cross. Now when I go to plug in negative 8/5 for x, I'm going to think of this 1 as 5/5. So negative 8/5 plus 5/5 is negative 3/5. So I'm going to write that down here, negative 3/5. And let's see if that is reasonable based on the graph that we came up with. So negative 8/5 is about negative 1 and 3/5. And then we're going down negative 3/5. This seems very reasonable. I know sometimes when you get a fractional answer, you're second guessing yourself, but based on this rough sketch, it seems like we did a good job here. So at this point, after looking at this example, I'd like you to go and try the problem set associated with clip 6.